Hey everyone. So back again with a few quick updates. So haven't really done anything to change the actual behavior of my network, but what I have been doing is adding in some more debug statements. So the main reason for that, I think, is just that I'm at the point where it seems to be training pretty well, but I'm not sure exactly what it's learning. Anytime I have it play against a real person, it really seems like it's switching too much. It seems like, it's basically just sending Pokemon out there almost to absorb damage, and then it'll try and do one big hit rather than, maybe try and do some sort of like predictive attacking, kind of anticipating when they would switch or trying to take advantage of the current matchup, even if it is favorable. So, yeah, trying to get to the bottom of why that's happening. And so I've added in a couple of the debug statements that I had in my DQN bot. So, things like the expected damage from moves, the state of the battle, so things like my Pokemon versus their Pokemon. And so we can see this now here in, this example output. So here's our embedding, so we can see the sort of expected damage of moves. This is on a scale that I believe goes all the way up to 90, but something like a value of 10 would be incredibly good. It's just I don't know, maybe I should look at that a little bit more mathematically. But anyway, so basically we have our expected damage. We can see our accuracy on a scale of 1, our matchup estimates, which are coming from that sort of battle function that estimates a matchup. We have our healths of our party, the healths of our opponent's party, and then our speed comparison, which will be 1 or -1, depending on if we're faster or slower. And, we can see here, for example, we have a Typhlosion and a Mamoswine in our party available to us, but out we have this Pokemon, and then our opponent still has 4 Pokemon available, and they currently have Landorus out there. So you can see now you can just follow the battles a little bit easier. And one thing that I was able to add in, which I think will be really helpful, is this distribution print statement here at the end. So if we go back to where we're actually training, so this doesn't print out, or actually rather, this is only during our testing that we print this out. But essentially what I do is I grab the policy that's available on my model, and then I go ahead and I convert the observations that we get back into, a tensor, and then I pass that into this get distribution function. And what that does is this actually makes a distribution of what is the expected action given our current observations. And so this really allows me to see like how the bot is learning. So for example, these first 4 are the probabilities that we should use the actual attack action. So attack 0, 1, 2, or 3. So in this case, we can see that the best available attack seems to be this guy, the third option, which corresponds to, let's see, Photo Geyser, I guess. Not sure how you pronounce that. But anyway, that seems like the most likely attack option. But if we look down here at these 2 values, these are the values of switching to one of our other Pokemon. So if we were to switch to a Pokemon, it seems like Mamoswine would be the most likely Pokemon we would switch to. And so currently I have the bot training on a big like data set of like 200,000 steps to kind of look at these values a little bit closer. But yeah, hopefully this gives some more insights into what it's actually learning, and I can learn how to tune it accordingly. So that's it for now, but I'll keep you guys posted with more updates.